Okay, so last lesson we have talked about two kinds of reactions with aldehyde and ketones. So the first quick revision. The first one we already talked about is the oxidation of aldehyde. So if we put potassium dichromate in acidic condition, we can further oxidize aldehyde to carboxylic acid. But ketone would have no reaction with acidified potassium dichromate. Okay, so that's a quick revision from the previous part. And then I also mentioned the second type of reaction with aldehyde and ketones. So here we can also do reduction to turn aldehyde or ketone back to alcohol. So just doing it the other way. So for reduction here, we have two kind of reagents we can choose. Okay, so can you still hear me clearly, or shall I slow down? Okay, so here we can choose one of the reagent. The first choice is lithium aluminium hydride, and the condition should be used with dry diethyl ether, or just dry ether. Okay, and then it's a two-steps reaction. So first, after you treat it with lithium aluminium hydride, then you need to put it in acid. Yes, it's a new parts. Okay, so make sure you have downloaded the new parts, the last part of this unit on Google Classroom. Okay, so the second reagent we can use to do reduction is sodium borohydride. And remember, for sodium borohydride, the solvent we can just choose water. Okay, it doesn't have to be anhydrous.
你26版第26頁你有冇教到㗎？
Yes, for the previous 2 pages, I've uploaded the videos onto Google Classroom.
我未睇。
Yeah, so you can check later. So it won't affect your today's lesson here. Okay, so that's the two reagents that you can use to reduce aldehyde or ketone back to alcohol. So today we're going to learn some more reactions. So first is the addition of hydrogen cyanide.
27版係咪都已經 upload 上去？
Yes.
Oh.
26 to 28 all uploaded to Google Classroom. And then, yes, so here, part C, we have the reaction, which is the addition of hydrogen cyanide, HCN, to form a hydroxyl alkane nitrile. Right, so for this one, you just need to remember on the structure. So originally you have the CO carbonyl group, and after that it will be changed into a hydroxyl group and also a cyanide group. Okay, so you can see on the structure, the carbon chains stay the same, but then you just add 2 groups onto that carbon. Originally has a carbonyl group attached to it. Okay, so you turn C11O to COH and CCN. Okay, so you need to be able to work out the products. And also you need to remember the mechanism. Okay, it's not in the dotted line, so you need to remember this part. So again, it's a 2-steps reaction. So first, the cyanide group, because it got lone pair on it, it would act as a nucleophile. And remember, the nucleophile would attack the positive charge or partially positive charge. So this carbon, because it's double bonded to oxygen, oxygen is more electronegative. So it would attach this carbon. Yes. Maybe let me finish the mechanism and then I will post a recording so you can ask. Right, so after the lone pair attack the partially positive charged carbon, it will push the electron towards oxygen, and then you will form this intermediate. And then, because the lone pair on the oxygen now, it will then attack the hydrogen on the HCN hydrogen cyanide, and then reform the cyanide ion. Okay. So, any question for here? Okay, so here, pay attention to this sentence. So here it said racemic mixture will be formed as cyanide ion can be attacked to the carbonyl compound in either direction, from above or from bottom. So what does this sentence mean? I would like to show you the model how this works. Okay, so here we got the molecule, right? So you can see for the example I gave on the notes, it's a symmetric alkene, so it doesn't really matter. But if I have this molecule, you can treat the black one as carbon, and there are two different alkyl group attached to that carbon, so it's an asymmetric alkene. Okay, so here this is an original CO double bond. Okay, it's carbon double bond to oxygen, and then if we have the cyanide group, I use red to represent the cyanide group. Okay, remember the nucleophile would attack the carbon, so it will break either the top bond or the bottom one. So if it comes from the top, so it will break this bond. Okay, so the cyanide group will add onto the top, and then the rest of the hydrogen now got a positive charge. You can see the lone pairs here. So it would further get the hydrogen from cyanide and regenerate the cyanide ion. Okay, so that's the first product it can form. Right, let me put it here. And then second, now I have the same molecule. Okay, like this one, same. Okay, I put the same direction. But here, my cyanide group are going to attack from the bottom. So you're going to break the bottom bond here. Okay, break the bottom bond, and then the cyanide group at here. And then this oxygen now got a lone pair. So here, the lone pair would take the hydrogen from HCN. Okay, so it will become this. Okay, cyanide group at the bottom. Right, now we got these two molecules. There's two. Right, so you can see if I rotate it a little bit, now they are racemic. Okay, so they are isomers, optical isomers, mirror image of each other. So if we have asymmetric alkene, because the cyanide can attack from the top or from the bottom, so it will form the optical isomers of racemic mixture. Okay, so that's the mechanism. Now let's move on to the next part. Okay, for this part, we're going to talk about three kinds of reagent. So this part, we talked about the chemical tests, right, to distinguish between aldehyde and ketone. So remember, aldehyde can be further oxidized to carboxylic acid. Okay, but ketone just stop there. It won't be oxidized anymore. So we can use this to set a test to distinguish aldehyde and ketone. Okay, so if we put it with a oxidizing agent, then the oxidizing agent will only react with aldehyde but not ketone. Right, so the first oxidizing agent we can use is what we have learned before, acidified potassium dichromate. Right? So for this one, we are changing dichromate to chromium 3 ion. Okay, so the expected observation would be from orange to green for aldehyde, but ketone would have no reaction, so it should remain orange. The solution should remain orange. Okay, so I have found the video, so we quickly check the videos together. Okay, so here you can see he got potassium dichromate, and then he got some sulfuric acid, and then he got aldehyde and ketone on the right hand side. Right, so the aldehyde he used is butanol, and the ketone he used is butanone. Okay. And then he's going to add the potassium, after adding the butanol and butanone, he's going to add the potassium dichromate. And make sure it needs to be acidified. So here we use sulfuric acid to acidify the solution. And then after acidifying, you're gonna give it a shake and leave it for some time. Okay, you can already see some changes for the test tube with aldehyde on the left-hand side. And if you wait a bit longer, you will see a more obvious difference. Okay, so up to this point, if you gently warm it, it can speed up the process. So you can see on the left-hand side, the color changed to greenish color. Okay, but on the right-hand side, the color remains the same. It's the same color as the potassium dichromate solution. Okay. So this is a way to distinguish between aldehyde and ketone. Maybe I quickly go through the next two as well. And then we got the tolerance reagent. Okay. Also, sometimes it's just referred as a silver mirror test. So on the right-hand side, you can see the expected observation. It formed a shining silvery surface on the test tube. So that's why it is called the silver mirror test. Okay, so for this one, it would react with aldehyde only, and during the reaction, the silver ion would become silver. That's why it formed the silvery shiny surface on the test tube. Okay, and again, for ketone, since it cannot be oxidized, it will have no reaction. And for the tolerance reagent, when we prepare it, it would happens in two steps. So the first step, you would add, okay, this is not compulsory, just for your information. So the first step, you add silver nitrate together with some very small amount of sodium hydroxide, a little amount. And then you are going to add, then it's gonna form some precipitate. I'll show the video, you will see it. And then you need to add aqueous ammonia solution, okay, until no precipitate is left in that solution. And then you will get your tolerance reagent. And the active part of that reagent is this complex ion. This one, that's the active substance that would distinguish aldehyde from ketone. So for this complex ion, because ammonia is neutral, carries no charge, and silver ion carries 1+. So overall, this complex ion should carry a positive charge. Okay? So again, let's watch the video. Okay, so this is what you're gonna see after you add silver nitrate with sodium hydroxide. Right, so now he is adding silver nitrate together with sodium hydroxide. Okay, so only small amount is needed, and then after you shake it, it's gonna form the precipitate. The precipitate is silver oxide. And then you will add aqueous ammonia and let the precipitate to dissolve. And you need to always prepare the fresh tolerance reagent to test for aldehyde. Because if you leave it for some time, it will go back to silver oxide again, the precipitate. And now you're going to add some sample to it. And then you can see there are some silver gradually formed in the test tube. Okay, so you can leave it at room temperature for longer time, or you can speed up the process by putting it on a warm water bath. Right, so after some time, you will get a perfect silver mirror in the test tube. So that proves the sample is aldehyde, not ketone. Okay, so that's for the tolerance reagent. All right, so you need to remember aldehyde will be oxidized to carboxylic acid, and the active substance, silver ion, will change to silver. Okay, and then the next one is a Fehling's reagent. So for this one, the active reagent is the copper-2 ion in the complex. And then after the reaction, aldehyde will be oxidized to carboxylic acid, and then copper will be reduced, copper-2 will be reduced to copper-1. Right, so the expected observation will be the color change from blue to the, what do you call this, reddish brown color, right here. And for this part, the Fehling's reagent, it usually contains two parts. So the first one, or you can call the Fehling's A or Phylling 1 reagent, will contain the copper-2 ion. So usually copper sulfate solution. And Phylling B, it will be containing potassium sodium tartrate. Okay, and also you need to add sodium hydroxide. Again, it will make more sense if I play the video to you. So you can see labeled on the left-hand side, the blue reagent is Phylling A or Phylling 1 reagent. And the next one, labeled F2, that's a Phylling B, the second reagent. And then you also need some sodium hydroxide, and then your sample. All right, and make sure Phylling A and Phylling B, you use equal amounts. And then after that, keep putting the aldehyde sample. So here he used ethanol. And then put into water bath, gently warm it to speed up the process. And then the expected observation would be copper-2 changed to copper-1. Okay, so you can see the color change formed from the top to the bottom. Okay, so after settle for some time, you will see the copper 1 formed. Okay. Okay, so these are the 3 reagents that we can use to distinguish aldehyde and ketone. So for this part, what you're going to be asked to reproduce is that you need to be able to recall the structure of the aldehyde. So you need to draw the structure of the aldehyde given in the question. And then you need to remember the active substance in that reagent. Right? For example, it's silver ion for Tollens reagent and copper 2 for Fehling's reagent. Okay, and then you need to work out the product. Yeah, so the carboxylic acid, and then for the first acidified potassium dichromate, it will be chromium 3. And of course, you need to remember silver is formed for Tollens reagent, and copper 1, okay, copper 1 oxide is formed. So you need to remember that. And the hydrogen ion is here to balance the equation. So if you remember these 2 products, then you would be able to balance it by adding hydrogen ion onto it. Right? That's all you need to remember for this part. Okay, let me repeat again. The part you need to remember for acidified potassium dichromate, you need to remember the active reagent here, okay? Dichromate ion, and then it's acidified, so H plus need to be there. And then you would change to chromium 3. And of course, if you need to balance the equation, you need to add water to do that. Okay, so I'm not worried about that part. For the second one, Tollens reagent, except aldehyde, that's going to be given in the question, you need to remember the active substance is silver ion. After the reaction, you're going to change to silver. Okay? And then, of course, you need to balance it using water and hydrogen ion. And for the third one, Fehling's reagent, except aldehyde, then you need to remember the active substance should be copper 2 ion, and would change to copper 1 oxide, the red precipitate. Okay, and then you just need to balance the equation, and that's all.